Welcome everyone to this lecture on a quick overview of data visualization. We'll teach you how to use Matplotlib for data viz as well as Panda's built-in data visualization. Let's open up a new Jupyter Notebook and get started. Alright, we'll start off with a couple of imports here. NumPy, Pandas, and then we'll also say import matplotlib.pyplot as PLT. And then the next thing we're going to do when we're working with Jupyter Notebooks, in order to see the visualizations in line with the notebooks, we need to have this %, matplotlib space inline. And that's known as a magic command. And this magic command only works in Jupyter Notebooks. If you're not using a Jupyter Notebook, that means that after you have all your plot code, you're going to type in plt.show, open and close parentheses, in order to actually see the plot. Okay, we don't need to do that since we're in the Jupyter Notebook. So let's actually show you how to do a really simple plot with Matplotlib. And most of the plots in this course are going to be really straightforward. We're either just going to use Matplotlib to show an image, or we'll kind of show some sort of curvature. So I'm going to create a NumPy array. Let's say 0 to 10. So if I take a look at x, it's just 0 to 9 there. And then we're going to say y is equal to x squared. And then in order to plot something like x versus y, you just say plt plot and then x comma y, hit enter, and that creates this nice little 2D line plot. Now as a third argument, what you can do is you can pass in a string code for a marker, and if you pass an asterisk there, it kind of puts in little stars. If you pass in a color code, such as for instance red, it will make that line red. There is a lot more detail to this, and it's not just a bunch of string codes to memorize. If you do Shift Tab here, there's kind of a list of arguments, and if you expand on this, it will tell you various things here. So R plus has red pluses, etc. And if you keep scrolling down, it'll tell you the various characters, the description of the line styles, as well as the colors that you can add to it. We really don't focus that much on data visualization in this course. We just use really simple plots. So really all you need to know is x versus y, and then some sort of string code that will allow us to kind of differentiate this. Okay, so kind of as a last example here, we can do like a red dashed line with something like that. Something you may find yourself needing to do is to kind of edit the x-axis and y-axis. In order to do that, in the same cell as your plot command, what you need to do is say plt, and you can pass in an x limit, and then pass in the limits. So notice here that it kind of has some extra space after 0. If you wanted to clear that, you can kind of hard code it in, set the x limit at 0, and then maybe you only want to go to 4. So you pass that in, and you can see now we have 0 to 4. And since the y-axis is still defined by the original auto-set y-axis, what we can do here is say plt ylim and make that go from, let's say, 0 to 10. And there we can see the various points here. And it's essentially just plotting out the points and then putting a dashed line between them, which is why as you zoom in, it gets a little more jaggedy. And in case you ever want to put titles or X labels on your plot, you can use plt title to title your plot. So you just pass in a string there and it shows the title on top. And I'm a little zoomed in here, which is why it looks blurry, or a little blurry. So if I zoom out, it kind of starts getting a little clearer. Then we can say plt to .x label to have some sort of X label. So let's put an X there. And there you can see now I have an X label. And as you may have guessed, if I just kind of copy and paste this, put a Y label here, make that Y label, I also get a Y label. Keep in mind, all of these commands need to go in the same cell, otherwise Matplotlib isn't really smart enough to know what plot you're referring to just with these plt.commands. Another plot that we're going to be doing a lot, especially when we work with images of convolutional neural networks, is an imshow plot, where we essentially kind of show an image on a 2D array. So I'm going to create a matrix. We'll say nparrange 0 to 100, and then I'm going to reshape this 10 by 10. So if I look at my matrix, it's essentially just a bunch of values that keep getting higher and higher. So if I wanted to plot this out as kind of a two-dimensional color scheme, what I would expect is some sort of color gradient that row by row it keeps getting brighter and brighter, and also column by column it keeps getting brighter and brighter, or darker and darker depending on how you think about it. In order to do that, what you need to do is say plt imshow, and this can take in a two-dimensional array here and then define the color by the actual value. So if we just pass in our matrix here, I can see what we expected, which is a lighter and lighter color mapping. And you can actually declare what kind of color map you want using CMap. You can pass in a string code here, and you can check out the documentation for the various string codes, but cool warm is another one here. And if you accidentally spell something wrong and you scroll all the way down here, it eventually says, hey, this color map wasn't recognized. Here are the possible values, and there's tons of possible values here. And you can check out the documentation to see what each of these colors look like. But we can kind of just grab one here. And this one may or may not look that great with this data. But here we have kind of a red, yellow, green. So you can see it starts red, yellow to green. So that's imshow. And just to kind of show it again one more time, let's now create a random value here. So we'll say rand int. Let's go 0 to 1,000. And then let's have the size be 10 by 10. So that's my matrix now. It's just a bunch of random numbers. So if I say plt.imshow here on the matrix, now I can see kind of a bunch of random squares there. And if you want a color bar, all you have to do is say plt.colorbar off of this, open close parentheses, and then you can see a color bar indicating the range of the values themselves. So that is matplotlib as far as plotting is concerned. Pandas actually has its own built-in visualization capabilities that run on top of matplotlib, kind of more like a nicer API call from a pandas data frame. We won't use it a whole lot, but just in case you're interested in it, we can say df is equal to pd read CSV. We're going to use that salaries file from last time as well. And then if we check out that salaries file, let's say we wanted to do a scatter plot of salary versus age, then I can just say df plot, and then it's basically expecting an x, a y, and then a kind of plot. So I can either do a line plot or I can do something like a scatter plot, which makes more sense for 3 points. So we'll say x, and then as a string you just pass in the column name. We'll say y is age. And then finally we'll say the kind is a scatter. Run that, and now we can see we have a scatter plot right off of our pandas data frame. There's lots of different plot types that pandas supports, and you can check out the documentation. We really won't be using that many of them, but if you check out dfplot dot and then hit tab, you'll notice the various kind of plots that pandas supports. And these are all built off directly of matplotlib, which is why the styling looks so similar. Okay, that's really all you need to know. We'll essentially just be using imshow a lot for images, and then we'll be using things like dot plot for simple graphs. Okay, thanks everyone. See you at the next lecture.